Hey engineers, and welcome to part 3 and the final part of 3.1.4. And you saw me use these in our last section. They are if statements. Now an if statement is different than an else or a while statement, because a while, it will continually loop. A while loop, you saw I had a while loop. While I'm going to check this, while the timer's less than 5 seconds, I'm going to keep looping through these parentheses. So here's my my matching brackets. I'm going to loop this, everything inside of here. A loop continually goes. An if statement is a trap. It only checks it once, and then it goes to the next thing. It will not continue to do something. You have to have a while loop to continue to do something, and if is a trap. It just checks it once, and if it's not, it goes on and it never returns. My if statements, they also have their own curly braces, and again, I cannot stress to you enough. The most important thing when you do your code is to be neat. You have to. And you know who you are out there. Some of you are not neat individuals. And I'm going to need you to break that if you want to be a successful coder. I need you to be neat, because you're going to raise your hand and you're going to say, Mr. Hare, this doesn't work. And number one, if you did not indent, I don't even look at your code, because it's going to take me 20 minutes to figure out what you did. Number two, if you don't put your comments in, I'm not even going to look at your code, because I don't know what you're trying to do. So indent, comments. I can't stress it enough. All right. If then, else statements. So again, it's a trap. You look for it. If some condition is met, then you do what's inside of it. And if the condition is not met, it just skips right over. You can use an else or an else if as like another trap. So you can just continually set like traps for it to go into as the computer goes down through the code. Be careful. When you're using two separate if-else statements, if you're trying to control the same thing, they could potentially fight one another, because your first trap could catch it, turn the motor on forward. Then your second trap could also catch it, turn the motor on backwards. So which is it? I mean, it's continually going down, and now your machine isn't going to work because it's telling it two separate conflicting ideas. Here's an example where if you push the button, then start the motor, but then you'll notice at the end, stop the motor, right? So if you're not pushing anything, stop the motor, but you're immediately going to have it stop if nothing else is pushed. Because, again, remember, this trap right here, if it doesn't, then it's going to flip down here. It says, in this example, if one of the touch sensors is pressed, the right motor will be turned on in one if-else statement and immediately turned off in the next. So what you could do to solve this is you nest them. So you put it inside of, and you'll notice, do you see how, so if you push the bump switch, then start the motor. But what if you don't push the bump switch? Okay, so else. Now notice that these are inside of their own little level. So you're going to check everything inside of here first. So, okay, now if you push the limit switch, then turn it on backwards, else stop the motor. So you're checking things in kind of a sequential order, and you're not going to have it fight itself. This is what we call, I said it before, it's a nested. So you're putting it inside of another one. So you can use an else statement. So instead of saying else and then also putting an if, then you can combine them into one whole line, else if sensor value limit switch is pushed. So you can do, sometimes you can be more efficient if you want to put one line of code versus, and you can see that there's a little bit less code on the right than on the left. Using a range. So what if you want, check this out. We want to control a motor with a potentiometer. Basically, if the potentiometer is on the first third, stop it. If the potentiometer is in the middle, go half speed. And if the potentiometer is towards the end, go full speed. So here's the challenge is control a motor with a knob. And you saw before in 3.1.4 part 1 how they did that. And that was really kind of neat. But here, if you only want 3 speeds, stop, middle, and full speed, how would you do that? A couple different ways. So number 1, what you could do, you could say if the potentiometer is less than or equal to 500, stop it. Now watch this. This is really important, kids. What if it was equal to 500? And this is where people make mistakes in their code, is that if it equals 500, it's definitely going to be stopped. Right? If someone had just written in their code, if it's less than 500, and then now you have greater than 500, well, what's supposed to happen if it actually, because what if you landed exactly on 500? This thing isn't going to know what to do, and so nothing's going to happen. So you want to make sure that you cover all of your bases. It goes back to in math class. Remember when you had those step functions where you had like open dot, close dot, open dot, close dot? Like, what do you do at 500? Oh, it's definitely here. It's supposed to be stopped, right? So make sure that you're covering every single possibility when you start using your less thans and your greater thans. Very important. Okay, so if it's greater than 500 and, so here's that and again, and it's less than 1,000. So if you're in between 501 and 1,000, then you go half speed. And then if you're greater than 1,000, full speed. And you're always going to check this, that while 1 equals 1, you're going to continually loop this thing forever. So here's a way to do this using and functions and using your if statements. So it's going to show you how to do this more streamlined. So now we did it. What you could do is you could make pitfalls like flags. So if it's less than 500, you're going to stop the motor. So, but then notice here, else if it's less than 1,000, because the only way it's going to get into this trap is if it passes the first one. So let's say the knob equaled, let's say the knob equals 1,500 right now. So it's going to go past the first one, and then it's going to get into here, and it's going to bam. It's all automatically going to do that. So here you can do the exact same thing with a little bit less. By using a little bit logic, you already know if you're going to get into this one that it's bigger than 500. And you can do this even, and you'll see, and the only way, check this out, like the only way you're going to get into this one is if you're already over 1,000. Shoot, I meant to say it's less than 1,000. So the only way you're going to get down here is that if you're already over 1,000, if you're already greater than 1,000. So you can kind of set yourself little traps, doing it a little bit more efficiently. That's what we've got for you, kids. While loops, timers, and if then else. This is probably in your coding journey, understanding the difference between while loops, how to control timers, and how to use if then else statements. Those are really, really important parts to anyone's coding journeys. So understanding what they're good for. A while loop is always looping and checking, looping and checking. An if statement checks it once, and then it skips over. So if and then else things, you can get them skipping over each other. And then timers, you can use them for time. Come back to this stuff. You're going to be using these 3 pieces a lot in the upcoming code. So make sure you get this down. And make sure that you write down the you'll know it now, but in like a week, you'll be like, shoot, how do I clear a timer? How do I do that? It's really important to take some notes to know for future you to get some help.